I am using KFold, a popular cross-validation technique in scikit-learn, to evaluate machine learning models. It's a resampling procedure used to reduce variability and get a better estimate of model performance. Break time 300 milliseconds. KFold divides the data into K groups and iteratively trains and tests a model K times, where each time a different group acts as the testing set and the rest as the training set. Break time 300 milliseconds. This helps to avoid overfitting and obtain a more robust evaluation. Break time 300 milliseconds. This is the question I am tackling. I will need to understand the parameters of the KFold function and how they affect the splitting of the data to answer it correctly. Break time 300 milliseconds. I am using scikit-learn's KFold, a function for performing KFold cross-validation. I am working with a dataset containing 15 samples. I set the number of splits n splits to 5, meaning I want 5 folds. I also set shuffle true so the data is randomized before splitting, preventing bias from the order of the data. Break time 300 milliseconds. Additionally, random state 42 ensures that I obtain the same random splits if I rerun the code, which improves reproducibility of my results. Break time 300 milliseconds. I am working with a dataset containing 15 samples. Break time 300 milliseconds. The number of samples influences the size of each fold. Break time 300 milliseconds. I am using the KFold function with these specific arguments. N splits 5 creates 5 folds. Break time 300 milliseconds. Shuffle true randomizes the data before splitting to ensure the folds are not simply consecutive portions of data, avoiding potential bias. Random state 42 sets the seed for the random number generator, guaranteeing that I obtain consistent folds across multiple runs, making my analysis reproducible. Break time 300 milliseconds. The data is split into 5 separate folds. The size of each fold may not be perfectly uniform, depending on how the data is shuffled and divided. Break time 300 milliseconds. I am setting the number of folds for cross-validation to 5. This means I'll divide my dataset into 5 different parts. The result of splitting the dataset into 5 folds is instructed by n splits 5. I'll randomly shuffle the data before splitting it into folds. The random state parameter ensures I get the same random shuffling every time I run the code, making the results reproducible. Think of it like setting a seed for your random number generator, so you get the same random sequence each time. I am working with a dataset that contains 15 samples, or data points. Each of these samples will be assigned to one of the 5 folds. This means I randomize the order of data samples. Think of shuffling a deck of cards before dealing. Google-style name conversational. This is crucial for avoiding bias. Otherwise, consecutive data might end up in the same folds, which might not be good for training a model accurately. Google style. I'll explain this statement about break time 100 milliseconds KFold cross-validation. Google style name lively. It's a bit tricky, but I'll break it down for you. Google style break time 300 milliseconds. Imagine we have 5 folds. Each time, we'll select one fold as our testing set. The remaining 4 folds break time 200 ms become the training set. So, each data point is used once for testing and 4 times for training. Break time 200 milliseconds. That's why it's not exactly one fold for both. Break time 300 ms. It is 4 training sets and 1 testing set across the 5 folds. This is simply the format of the question in the context. We need to apply our knowledge of KFold to answer this. This tells scikit-learn's KFold function to split the dataset into 5 folds. This is a parameter that controls the number of splits in the KFold cross-validation technique. K represents the number of folds we make in our data. We are working with a dataset that contains 15 data points. This is the size of the data we are applying KFold cross-validation. This refers to the process of splitting the dataset into the folds. The method used is KFold, which is mentioned above. This describes the overall setup of the problem. We're using KFold cross-validation, a resampling procedure used to evaluate machine learning models on a limited data sample. I am using scikit-learn's KFold, a powerful tool for cross-validation, to evaluate a model's performance on a dataset containing 15 samples. KFold is short for KFold cross-validation. This is the question I am tackling. I am setting up a 5-fold cross-validation with shuffling and a fixed random seed. I want to determine which statements accurately describe the resulting folds. Let's break down this setup. I am using scikit-learn's KFold function to perform cross-validation. This means I am splitting my data into multiple subsets folds to train and test my model repeatedly, which helps obtain a more robust performance estimate. Here's the core of the problem. I am using 5 folds n splits 5. The data is shuffled randomly before splitting shuffle true, and the random seed is set to 42 random state 42. This last part ensures that every time I run this experiment, I get the same folds, making the results reproducible. I have only 15 samples in my dataset. This is an important piece of information to consider when thinking about how my data is split into folds and how many samples each fold will have. It's not an even division, so expect some folds to have slightly more or fewer data samples than others. This statement is incorrect. In KFold cross-validation, each sample actually appears in one fold as a test set and in the remaining folds as training data. It's not just one training fold. Google style name excited. This is true. Google style break time 300 milliseconds because I set shuffle true. The samples get a random shuffle before splitting into folds. This prevents bias from the order in which the data is presented. This is false. Google style name talkie KFold does not inherently do stratification. Google style break time 300 ms. Stratification is needed if you want to ensure the class proportions in each fold are representative of the proportions in the whole dataset. That's something to consider separately. I'd use stratified KFold if I needed stratified folds. This is false because 15 samples divided by 5 folds equals 3. But KFold doesn't guarantee perfectly equal-sized folds. It's not about equal division, it's about dividing the dataset into K chunks for robust evaluation. I am using scikit-learn's KFold, a technique to evaluate machine learning models. KFold divides your data into K groups folds for cross-validation. Here, I have 15 samples, meaning 15 data points to split. The question tests your understanding of how KFold works with specific settings. Well, examine the effects of the different parameters. I have a dataset with 15 data points or samples that need to be split into folds for cross-validation. I've set the number of folds to 5. This means that my data will be split into 5 different groups, each used once for testing and the rest for training. N splits is short for number of splits. I am shuffling my dataset randomly before splitting. This is important because it prevents bias due to the order of the data. To ensure that my results are reproducible, I've set a random seed. Setting random state to 42 means that every time I run this with the same parameters, I will get the same random shuffling. I am using scikit-learn's KFold method, a popular technique for cross-validation. It helps me evaluate the performance of a machine learning model more reliably by splitting K data into multiple folds for training and testing. Break time 300 milliseconds KFold stands for K folds. Break time 300 milliseconds K represents the number of folds you create. I have a dataset with 15 samples, or data points, that I'll use to train and test my model. I've set the number of folds, or splits, to 5. This means I'll divide my 15 samples into 5 different groups. I am shuffling the data randomly before splitting it into folds. Break time 300 milliseconds. The random state is set to 42, ensuring that the shuffling is reproducible. Break time 300 milliseconds. If I rerun my code with the same random state, I'll get the exact same folds every time. This is important for repeatability and comparison. This is the first of my 5 folds. It contains a subset of my 15 samples. The second fold another subset of my 15 samples, independent from fold 1. The third fold, containing a different subset of my data. The fourth fold, another subset. The fifth and final fold, containing the remaining samples. I am asking you to determine which statements are true about how scikit-learn say as. Interpret as characters KFold. Z is cross-validation splits a dataset with 15 samples into 5 folds. Well, consider the impact of shuffling the data and using a specific random seed. Break time 300 milliseconds. I used scikit-learn say as interpret as characters KFold. Z is function with 5 folds say as. Interpret as characters n splits 5 say as. Data shuffling enabled say as interpret as characters shuffle true say as. And a random seed of 42 say as interpret as characters random state 42 say as. This ensures the splits are reproducible. Break time 300 milliseconds. The say as interpret as characters KFold. Z is function divides the dataset into 5 different folds, each used once as a test set and 4 times as training sets. Break time 300 milliseconds. I am performing 5-fold cross-validation using say as interpret as characters KFold. Z as on a dataset containing 15 samples. I am working with a small dataset, just 15 samples. This will make the impact of the fold division more pronounced. This statement is incorrect. While 15 samples divided by 5 folds equals 3 samples per fold, say as interpret as characters KFold. Z is doesn't guarantee perfectly equal-sized folds. It performs integer division, leading to some folds having 2, 3, or 4 samples. Break time 300 milliseconds. This is correct because I set say as interpret as characters shuffle true say as. Before creating the folds, say as interpret as characters KFold. Z is shuffles the samples. Break time 300 milliseconds. This is incorrect. Say as interpret as characters KFold. Z is doesn't inherently perform stratification. Stratification means that class proportions are maintained in each fold. To achieve stratification, I'd use say as interpret as characters stratified KFold. Z is instead. Break time 300 milliseconds. This is correct. Each sample appears in 4 folds for training and 1 fold for testing across the 5 folds of the cross-validation. Think of it like this: each sample gets to be in the test set once and the training set 4 times. Break time 300 milliseconds.